Hello, welcome students. I am Rekha Thorat, Associate Professor. Today we consider particular integrals when x equal to sine of ax or x equal to cos of ax. That means when operating factor is sine of ax or cos of ax, we find particular integral. To prove this result, here particular integral equal to 1 upon fd sine of ax or 1 upon fd cos of ax. To find this, we first find the derivative of sine of ax. Derivative of sine of ax is, derivative of sine is cos, and ax, derivative of ax is a. So derivative of sine of ax is a cos of ax. D square of sine of ax equal to d of sine of ax equal to d of derivative of sine of ax is a cos of ax. We take constant outside, so that a into bracket derivative of cos of ax equal to a into derivative of cos of ax is minus sine of ax into a. So we get d square of sine of ax equal to minus a square sine of ax. Again we proceed further, as d cube of sine of ax equal to d into d square of sine of ax equal to d into d square of sine of ax is minus a square sine of ax. Minus a square, it is constant taken outside. D of sine of ax is a cos of ax, so we get minus a cube cos of ax. Then we find d raised to 4 sine of ax equal to d into d cube of sine of ax equal to d into d cube of sine of ax is minus a cube cos of ax. Minus a cube constant term, so minus a cube into d of cos of ax, and d of cos of ax is minus a sine of ax. So finally we get minus a cube into minus a, that is a raised to 4 sine of ax, and this can be written as d square bracket square into sine of ax equal to minus a square bracket square into sine of ax. Then we find d raised to 5 sine of ax. We find d square bracket square sine of ax equal to minus a square bracket square sine of ax. Then we consider d raised to 5 sine of ax equal to a raised to 5 cos of ax. Since d raised to 5 sine of ax equal to d into d raised to 4 sine of ax, but d raised to 4 sine of ax is a raised to 4 sine of ax. So we get a raised to 4 taken outside. Derivative of sine of ax is a cos of ax. So finally we get a raised to 5 cos of ax. A raised to 5 cos of ax. Then we find d raised to 6 sine of ax. D raised to 6 sine of ax equal to d into d raised to 5 sine of ax equal to d into d raised to 5 sine of ax is a raised to 5 cos of ax. A raised to 5 constant taken outside into d of cos of ax, and d of cos of ax is minus a sine of ax. So we get minus a raised to 6 sine of ax, and this can be written as d square bracket cube sine of ax equal to minus a square bracket cube sine of ax, and so on. So in general we can write d square raised to n sine of ax equal to d raised to 2n sine of ax, which is equal to minus a square raised to n sine of ax. Since for d square bracket square, for d square raised to 2 sine of ax, we get minus a square raised to 2 sine of ax. D square raised to 3 sine of ax, we get minus a square raised to 3 sine of ax. So in general we can write d square raised to n sine of ax equal to d raised to 2n sine of ax equal to minus a square raised to n sin of x. Hence, f of d square sin of x equal to f of minus a square sin of x. Operating on both sides with 1 upon f d square, we get 1 upon f d square into f d square sin of x equal to 1 upon f d square into f of minus a square sin of x. F d square 1 upon f d square cancel. They are reciprocals of each other. They cancel with each other. So we get sin of x equal to f of minus a square is constant into 1 upon f d square sin of x. Hence f of minus a square is constant. So we divide by into LHS term. So we get sin of x upon f of minus a square equal to 1 upon f of d square sin of x. Hence 1 upon f of d square sin of x equal to sin of x upon f of minus a square. Thus we get this result. This result can be asked for objective also. 1 upon f of d square sin of x equal to sin of x upon f of minus a square. That means when there are terms of d square, then write minus into a square, f of minus a square, where a is coefficient of x operating factor, where f of minus a square is not equal to 0. Thus we get here, we divide by sin of x by f of minus a square, since it is not equal to 0, equal to 1 upon f of d square sin of x. Thus 1 upon f of d square sin of x equal to sin of x upon f of minus a square, where f of minus a square is not equal to 0. Similarly, we find the result for cos of x, that is 1 upon f of d square cos of x equal to cos of x upon f of minus a square, where f of minus a square is not equal to 0. We do same process as for sin of x. We take derivative of cos of x. Derivative of cos of x is minus a sin of x. D square of cos of x equal to d of cos of x equal to d of derivative of cos of x is minus a sin of x. Minus a is constant taken outside. Derivative of sin of x equal to a cos of x. Thus we get minus a square cos of x, that is d square of cos of x equal to minus a square cos of x, and this can be written as d square raised to 1 cos of x equal to minus a square raised to 1 cos of x. Now we find d cube of cos of x equal to d of d square of cos of x equal to d into d square of cos of x is minus a square cos of x equal to minus a square into d of cos of x is minus a sin of x. So we get minus a square into minus a, that is a cube sin of x, since derivative of cos is sin. Now we find d raised to 4 of cos of x equal to d into d cube of cos of x equal to d into d cube of cos of x is a cube sin of x. A cube is constant, derivative of sin of x is a cos of x. So we get here a raised to 4 cos of x. And this can be written as d square bracket square cos of x equal to minus a square bracket square cos of x, and so on. Similarly, in general we can write d square bracket raised to n cos of x equal to minus a square bracket raised to n cos of x. Hence, f of d square cos of x equal to f of minus a square cos of x. Now we operating on both sides by 1 upon f of d square. So that we get 1 upon f of d square into f of d square cos of x equal to 1 upon f of d square into f of minus a square cos of x. This f of d square and 1 upon f of d square, they are reciprocals of each other, hence they cancel with each other. So finally we get cos of x. Cos of x equal to f of minus a square cos of ax upon f of d square. F of minus a square is constant and not equal to 0. So we divide by LHS term. So we get 1 upon f of d square cos of ax equal to cos of ax upon f of minus a square, where f of minus a square is not equal to 0. Now this result can be asked as 1 upon f of d square cos of ax equal to dash dash. That is 1 upon f of minus a square cos of ax, where f of minus a square must be not equal to 0. And when this denominator is 0, then the result is calculated as follows. If this f of minus a square equal to 0, then d square plus a square is a factor of f of d square. Let f of d square equal to d square plus a square in bracket into phi of d square, where phi of minus a square is not equal to 0. Phi of d square is function phi. Instead of f, we take here function phi, since here f function is there. Hence, particular integral equal to 1 upon f of d square sin of ax equal to f of d square is d square plus a square into phi of d square. It is equal to 1 upon in bracket d square plus a square into phi of d square operated on sin of ax. Now we use the result 1 upon f of d square operated on sin of ax equal to 1 upon f of minus a square sin of ax, where f of minus a square is not equal to 0. Using this result for phi, this is same function as this is f and this is phi. So we use this result 1 upon phi of d square operated on sin of ax equal to 1 upon phi of minus a square sin of ax, and this d square 1 upon d square plus a square term as it is. But 1 upon phi of minus a square is constant, so it is taken first. It is constant term not equal to 0. So we get particular integral equal to 1 upon f of d square operated on sin of ax equal to 1 upon phi of minus a square into 1 upon d square plus a square sin of ax. Now we have to find this result 1 upon d square plus a square operated on sin of ax. To find this result operated on sin of ax or cos of ax, consider e raised to iax equal to cos of ax plus I sin ax. Hence, cos of ax equal to real part of e raised to iax and sin of ax equal to imaginary part of e raised to iax. Now, 1 upon d square plus a square operated on e raised to iax equal to factors of d square plus a square are d plus ia into d minus ia operated on e raised to iax. And we know that using the same result, and it is 1 upon fd operated on e raised to x equal to 1 upon f of a e raised to x. When there is d terms, put d equal to a, where f of a is not equal to 0. Here coefficient of x is ia, so we put here ia plus ia, that is 2ia. But if we put d equal to ia, then this term becomes 0. And this bracket is repeated only one times. So that using previous result, we get x raised to 1 upon 1 factorial e raised to iax, since this factor which becomes 0 by putting d equal to ia is only one time. So we get x raised to 1 upon 1 factorial e raised to ix. Simplifying this, we multiply both numerator and denominator by I. So we get ix upon e raised to ix divided by 2a into I square. And finally I square is minus 1, so that 1 upon d square plus a square e raised to ix means cos of ax plus I sin ax equal to minus ix upon 2a into e raised to ix, which is equal to minus ix upon 2a into bracket e raised to ix is cos of ax plus I sin ax. Here both are complex numbers in LHS and RHS terms, so we compare these two results. We compare both the sides LHS and RHS. So equating real and imaginary parts, we get 1 upon d square plus a square operated on cos of x equal to x upon 2a sin of x, and 1 upon d square plus a square operated on sin of x equal to minus x upon 2a cos of x. That is, when there is operating factor is cos, we get x upon 2a sin of x, and when the operating factor is sin of x for 1 upon d square plus a square, we get result as minus x upon 2a cos of ax. Thank you.